Hello, everyone. Thank you so much for coming. I understand that it's huge competition here with lunchtime, so we really appreciate your determination. So this session is going to be about shielded VMs. And I am product manager. My name is Nelly Porter, and with me is going to present or co-present a little bit later Andy Honig, who is software developer manager for the teams that develop shielded VMs. So this topic is going to be going a little deeper than everything that you heard about. Together with Andy, we will try to give you a little more information about what the shielded VMs are all about and what they're trying to do for you. The first and foremost, for every security talk that I've been, needs to be slide about our attackers. So we decided to not deviate this rule and put something that will scare you. So first and foremost, I think you all believe and agree with us that definitely attackers are becoming much more advanced. And that's really why we need to ensure that we have protections against advanced threat. And attackers are usually going after data, your user's data, your resources, trying to DDoS you, or maybe trying to do what they're supposed to do and trying to exfiltrate the most important secrets that you have. Also, sometimes, or all the time, I guess, attackers is trying to get credentials, and credentials will help them to get your VM and your resources and use them in whatever they need to do. And those credentials really needs to be really well guarded. So what we've seen so far is that to guard your data, to guard your secrets is not a trivial task, and it's more and more difficult as attack surface becoming more and more comprehensive. And our attackers also very much understand cloud and cloud scale and cloud automation. So what we've seen is one of the reports that we published last year demonstrates that if any VM started to be available online, literally in 4.6 minutes plus minus, this VM will receive first SSH attempt. And again, preferably, if it's not really well protected, it can be compromised. Also, any resources or any credentials that will be exfiltrated will be used literally in a few minutes. So they know how to do the craft, and it's really why we need to ensure that we are ready for that. You probably all agree that good security comes from the layers. There is no, again, defense in depth. It's very common things that everybody understood. And that's really why we actually started to harden our system starting from the bottom, from the the lowest level we can go. And you probably heard enough today about Titan, but we will repeat again why and what Titan is providing for us. So Titan is a secure chip that Google designed and Google developed. And this Titan security chip, it helps us to provide very important security controls for our infrastructure. So the first one that will be applicable to this talk is machine identity. And machine identity is done by the virtue of how we manufacture Titan. When we manufacture Titan, the first thing that we do, we have a set of keys that we infuse in the Titan. We burn it into the fuses so they are not extractable. We harvest those keys in our registry, and also it's Titan registry, and we issue certificates, 509 certificates to those Titans. And now what happened, those Titans can be challenged or asserted, and they can explain or cryptographically prove that they have possession of these keys, these Titan identity keys. So now imagine that you put this key on the motherboard or network card, And this motherboard you put in the server. Now this server can actually cryptographically prove that this server is belong to Google and standing in the right data center and provide any capabilities that we expect from server. So we called it machine identity. The second very important property and control that Titans offer to us is secure boot. So secure boot, again, probably it's well-known standard concept. You probably know about that. Otherwise, you will not come to our presentation. But secure boot is the idea that every single binary in your boot sequence needs to be signed by appropriate authority. And if we will figure out that something is not signed, we will stop your boot and boot of our system as well. Also, if, again, the interesting thing with secure boot, we're trying to provide even more higher security with our secure boot. And what we call this capability, it's called first instruction integrity. And despite of long name, it means very simple thing. It means before you execute anything, let's ensure that it was not tampered with or modified. And it's what we do with our firmware. So Titan, when you power up your server, is actually validating their own firmware. It's not trusting itself blindly. And after that, it's trying to help to validate the firmware of the machine itself. It does it because it has very important two properties. First of all, strategic location. Location, location, location. And what Titan is, it's sitting in between the flash that has this firmware and platform controller hub that actually reading this firmware. And the second interesting property that Titan has, it can keep your CPU at reset. And it means every single bit that PCH is reading from the flash is going through the Titan. Titan validated, and only after validation is complete, remove CPU from reset, release it, and now CPU can execute these instructions. So this capability we called first instruction integrity. And the last one, measured boot. And measured boot is the idea that compared to secure boot, it will provide much more detailed information about what is happening during boot sequence. And measured boot in our server machines ensures that kernel binaries that we're putting on top of our firmware and our bootloader is not tampered with or not modified. Why I'm talking about that today? Because as you can imagine, after we lay down our kernel and put and validated our hypervisor, KVM, and now we start it again. What I mean by that, now you bring your compute resources, and now when we started your VM, the whole cycle started from beginning. We need to have your firmware running. We need to ensure that bootloader is here. We need to run the OS, the boot sequence, and kernel, and all of that has to be somehow validated. And today, until shielded VM show up, it was not. So customers ask me, I'm product manager, very many times, if in my VM somebody compromised my VM and installed some backdoor, how do I know? And being very frank with you, you have no idea, literally. So what we want to help you to find these very advanced threats. And from attackers' perspective, they want to compromise your VM. They want to install malware and all other boot level and rootkit. The malware is actually incredibly dangerous. And the reason why it's dangerous, because it's precise beneath your OS. And when you starting your OS, you actually have no idea what is happening below you. And also, these threats are usually persistent between the boots. It means it has very long-lived cycle, and also they undetectable. So from our customers' perspective, they want to stop those VMs, those tampered VM from running, figure out what is happening, update them, patch them, help them, and after that, reestablish trust with those VMs. And also, very importantly, all secrets on those VMs need to be locked to those VMs or to the environment. And it's very important reason, because the passwords, auth token, anything of the value is usually global secret, and it's software bearer secret. And it means when attacker will exfiltrate it from single VM, it can apply it through lateral move to every VM that you have. And it's really a really bad idea. So what and how we can help you with? And it's today, again, yesterday, not today, we introduced public beta of shielded VMs. And shielded VMs is a product that help to protect against those advanced threats on your compute resource level. We want to provide, and we're providing, verifiable integrity and exfiltration resistance. And we offer it configured by default, enabled by default, and free of charge. So the questions that I'm receiving every single time, if it's so great thing, why not? And the answer is, please use it. It's actually a lot of value for you, for our customers. So what can you do with that? Let me explain you a little more. So we enable on your VM, we replace your old and rusty BIOS or your master boot record and replace it with unified extended firmware interfaces. Firmware is wonderful, it's very extensible. We're trying to not make it super extensible, but a few extensions are very important. And this extensions is secure boot. So we're enabling secure boot, similarly to what we have in our infrastructure for your VM, for specific subset of Google curated images. In addition to that, before I will go any further, in addition to that, we enabled virtual trusted platform module. The very long name, but it's crypto engine that very similar to our Titan, but it's virtual device, it's software that every VM will have their own. And VTPM, so virtual trusted platform modules, can do your crypto outside of boundary of your VM. It means any vulnerability of your kernel or user mode in your VM will not touch, will not change your cryptographic operation that VTPM perform for you. And VTPMs are actually the normal crypto engine. It can generate the keys, it can protect the keys, and it can attest the keys that is coming from these VTPMs. And Andy will talk again in details about what VTPMs can do. But one of the most important features that our customers like about VTPMs, now they don't need to trust blindly VMs. Their VMs, they can actually challenge, exactly as we challenge machines, and they can say, VTPM, prove to me that you actually part of this VM. And what's happening with VTPM, and it's standard, again, TCG, Trusted Computing Group specs, so it's absolutely standard TPM 2.0 interface that we enabled. We're becoming TPM vendors as well. So TPM pass all compliant tests. So TPMs have very interesting capabilities. They have this master key. It's called endorsement key. And we using our Google CA to issue certificate to those keys. And these keys are actually the most important thing, because then VTPM can attest a few things for you. So if you will challenge your VM and saying, okay, give me your, again, proof that I have this VM, in addition to the cryptographic attestation and signature, we're giving you triple information. And that's very important information. It's instance ID, it's the project ID, and the zone. And then you have cryptographic proof that it's the VM that you're really talking to. There is no way for anybody to change it, because it's tamper evident log that we provide to you as our attestation statement. And that's what we call strong VM identity. Based on that, you can decide if you trust this VM to share your secrets, or you are not trusting it very much. The second thing that we enabled, in addition to secure boot, is measure boot, very similarly to what we have in our infrastructure level. But in addition to what measure boot expected to do, utilizing this VTPM and measuring integrity of every single binary that we use in our boot sequence, and providing much more detailed information. For example, Because how this particular measurement is created, every single binary, before it's executed in your path, is hashed and added to the previous hash of all other binaries that already have been hashed. And when you're going through all of this cycle, by the end of the day, you will have this hash that you can compare with baseline. And we're creating this baseline for you first time ever that we running and starting this VM. And if we'll see that this runtime calculated attestation is different from our baseline, we're sending all of this information to you so you can take actions. Finally, you will not be blind. And if anything will change during this period of time, we're sending this information and you stack driver notification and alarms and all other functions. You can decide, stop immediately this VM. Literally stop, I need to extract it and go with forensic to figure out what is that. Because out of thousands of those VMs, one of them, integrity failed. Not a good idea. But if you know that this change is expected, absolutely legit, you updated something, you added kernel driver, you've done something that you understand, you have a way to rebuild this baseline and start measuring integrity of your boot sequence and kernel based on this new baseline that you trusted. It's actually very important when you need to reestablish your trust with this VM. If VM was compromised and you patched it, the question is how to reestablish trust, how to continue trust this machine. And we're providing you that. And verifiable integrity, you can actually see that and understand and take action. And VTPMs have very good opportunity to actually seal and protect your keys. And Andy will be talking about this in much more details. Let me show you a quick demo. And this demo is live, as you can see. So everything can be possible. So we're going to Google Cloud Console. And as usually, you will start off creating your instance VM. Nothing super, again, different here. You will give the name of this VM. You select, so we right now running beta. So this wonderful checkbox is unchecked. It means you have both options. You can select shielded VM option and non-shielded VM option for every single OS that we support. We shielded multiple OSs, as you can see, and you select it. Nothing fancy here. So you will notice that we added for this release, sorry, let me try it again. Yep. Let's go to 4, change it, show images. Let me pick shielded VMs this time. And as you can see in security tab now, all of these capabilities actually checked in. So now you have pre-configured secure boot, you have VTPM enabled, and you have integrity monitoring that's also available. We make it such that you would be able to opt out from this. If you will decide that you don't need some of these capabilities or some backward compatibility issue you will discover, so you're absolutely in control. But we highly recommend that you will not touch it. And then create, and you have shielded VM up and running. So, but usually, our customers do not create VM by VM by VM. They need thousands. They need really massive production. So for that, they're usually using templates. So let me show you how easy it is to create template for shielded VM. Let's pick Windows for this purpose. And again, exactly the same experience you have. You can opt out from some of the capabilities. Click Create. You have shielded VM instance template. And all what you need to do, the next step, is create a group, cluster of the VMs. And again, after I will put this wonderful name, you can specify the instance that you're going with. And it's the instance that we created literally a few seconds ago. So from this moment, I have this from 1 to 10 VMs that I can create. After I will click create. If I need from 100 to 1,000, I can set it up, and it will be auto-healing, auto-scaling, managed group of VMs that you can, all of them, use as shielded VMs. It's all my demo, and can we switch to the slides, please? Okay. Moving forward. So we didn't forget about separation of duties as well, because we believe it's critically important that only and only a few would be able to modify shielded VM configuration or enable, disable integrity policy, integrity functionality. So we added 2 additional custom permissions, IAM permissions, that you can add to custom roles. And we also added this to the default roles. We added to instance admin v1 and secure admin. So if you don't like, again, our decision on these IAM roles, you're more than welcome to create your custom roles and go with it. So what I want to kind of sum up for you is that shielded VMs provide significant value. Not because we created it and we love it, but we strongly believe that it's actually something that you can use and take and benefit from. It's actually reducing the trusted TCB, trusted compute base, something that you need to worry for your cryptographic operation. It's also removing, again, any vulnerability and threats that can happen in your VM for your crypto. It doesn't have performance implications. Sorry, it doesn't. Everybody couldn't believe me, and even my engineering team, but it's actually the reality. So it's very, very low latency. We will say it's kind of not equal. It does support live migration and live patching that all our customers believe have to be done, and it's hardware independent. We specifically didn't tighten it as pass-through to Titan, because otherwise your live migration will be in trouble. And it's attested and verifiable. A few more words about integrity monitoring. So with integrity monitoring, you can get your tamper-evident logs, because it's signed by VTPMs in your stack driver. You can monitor them, you can assign the actions on them, and decide what you want to do. So I have one additional demo for you to explain why it's so important. And it's more recorded because it's difficult to reproduce the attack, but we will try to, again, manufacture for you real attack. Can we switch to my laptop, please? Okay, so let's go with video. So you're booting from your new VM. The boot sequence is as you expect, kernel loaded, everything is fine. We calculated 80 hashes, we compared baseline, and pass to use it, everything is wonderful. So now if somebody will try to boot from different boot sequence, or even change the sequence of binaries in your boot, we immediately will find it out and provide for you 2 feeds. All information about that and very basic pass or fail indication of that. That's all. So can we switch to the slides, please? Sorry. And now Andy Honig, my partner in crime, will continue this presentation.
Thanks, Nelly. So I'm going to talk. Can everybody hear me? All right. So I'm going to talk a little bit more about the actual security properties it provides and how it works, and get more into the details. So I have up here the server security model, which is very, very vague, but basically, you've got your operating system, you have your VM, and you're worried about compromise. You want to be able to detect and minimize the damage if you do get compromised. And you do that with a variety of tools. You do it with antivirus, you've got audit logging, you've got intrusion detection, maybe some other kind of monitoring. There are things on the operation from privilege separation. But if you're an attacker and you want to break into something and stay in there long term, you can lie to all of these things, right? So our threat model is your attacker has broken in and has root privileges on your VM. So if someone has root privileges on your VM, can you really trust any of these things up here if you can't trust the thing down here? So that's really what shielded VMs is about. is making sure that once you have this lower level and you're certain that this isn't compromised and this is in good shape, then you can actually have some faith in the higher level things you have above that. So let's talk about how that works specifically. So here's a kind of example of Secure Boot. So Secure Boot's been around a long time, I don't know, 10 years, 20 years, something like that. And it's been around the real hardware world. So in real hardware, Microsoft mostly drove it, and they got a key baked into the firmware for a lot of OEM hardware makers. And that key is a public key, and it's baked in. And in the Google case, we control it, so we have our key. And then the private key is held by Microsoft or the distribution owners, or Ubuntu, or in our case, we have a copy for our container optimized image. And the people who make those images sign those images. So they have their own process for keeping those keys secure. They can have those keys offline. They can be a quorum of 3 or 5 people to do the signing. However secure they want to keep those keys, they can make those very secure. So that public crypto key is baked into our firmware. Then that signs the bootloader is signed by that private key. When the Google-controlled firmware comes up, the first thing it's going to do is it's going to check the cryptographic signature on that bootloader. And if the signature does not match, or if it's been modified, it won't boot. Then the bootloader then checks the signature on the operating system. It's up to the operating system just how much to measure there. Most of them measure the entire kernel and the drivers. And if those don't match as well. So if an attacker has gone in and he's changed your kernel drivers, which is where you'd want to change things if you want to lie to all of your intrusion detection systems and monitoring systems, then Secure Boot will fail to boot. So another thing that's often confused with it, but totally different, is measured boot. They go hand in hand. Measured boot relies on the virtual TPM. Again, TPM is a standard that's been around a long time. As Nelly said, we are completely compliant with the spec. It's been around, again, about 20 years. So measured boot, so Secure Boot solves a problem that says, am I in a state that has been signed by someone? Yes or no? And if yes, you can boot. If no, no. Measured boot tries to answer the question of exactly what state did I boot in? And it tries to answer it in a way so that after you've booted, you can ask and be confident about the answer. Because you can have a boot log. Windows has a boot log, Linux has a boot log, and you can go read that boot log. But if someone's broken into your kernel, how much trust can you really put into that boot log? So TPMs have hardware mechanisms called platform configuration registers, so PCRs. And the property of those is once you write to them, they actually can't be zeroed. They can only be extended. So as the Google-controlled firmware is coming up, it reads the bootloader and extends that into a PCR. Various other things like the Secure Boot configuration are put into that PCR. And then the bootloader will then measure the operating system and put that in the PCR, along with a variety of other things. And what that provides you is, if you read those PCRs later and they match, you can be absolutely sure that it has come up in the configuration that you expected. If they don't match, you don't know exactly what was wrong. You have a hint because there's different PCRs for different things. But if they do match, you can be absolutely certain, unless someone's broken SHA-256, but that's not very likely, that it came up in that state. The other thing that VTPM has is because the VTPM participates in the cryptographic protocol, it can remotely prove that to somebody else. So you can remotely prove to another system that your system came up in a good and measured state, and it was the right state. And in our case, you can do the remote attestation with the VTPM, or we actually short circuit that to make it easier because we control the cloud that you're running on top of to deliver that straight to you via stack driver, as she showed in the integrity monitoring demo. So VTPMs, as Nelly was saying, I've said they've been around a long time, so there's actually quite a few use cases. She talked about sort of strong integrity. She talked about protecting secrets, protecting cryptographic secrets. There's use cases around tamper-evident logging, and quite a few others. I'm really just going to talk about the binding and sealing use case. It's one of the more popular ones. It's used pretty thoroughly in Windows. There are some Linux applications that use it. Let's say you have a key, and you need to hold on to that key across reboots because it encrypts something or it says something important. And you want to keep it around, but you don't want to have it leak. So it seems like a pretty common use case. You don't want that. You don't want, if someone compromises your VM, reads all your files, or if someone gets a backup of your disk, you don't want that key going out, running around everywhere. So that's kind of what the binding use case is for. So basically, you generate your key, or you take your key, and you tell the TPM, bind to this TPM. So it will encrypt that key in such a way that only the TPM can decrypt it. And because the TPM is part of the hardware, that means you have to be on that machine, or in our case, that virtual machine, to get that key back. That's the binding use case. If some backup administrator, let's say you have a backup administrator who takes backup of your systems, tries to connect it to another VM, or tries to exfiltrate that data in any other way, your key is safe. A little bit more advanced is actually sealing. So I talked about measured boot, and I talked about how it will measure the state of your system. You can actually seal a key to that measurement. So what that means is that you take your key, the TPM will encrypt it, and it will only decrypt it later if you booted in the right state. So if you got some kernel rootkit in there and someone has changed your OS system and you try to get that key out, that won't work. This is one of the major use cases. This is how BitLocker works. So BitLocker says, if you turn off secure boot features that are part of this measurement and my system doesn't come up with those features enabled, you cannot recover your BitLocker keys. For example, if you were to take the entire disk and move it somewhere else and try to decrypt it, you would fail to do that, even though you got the entire disk, because the BitLocker key is exposed. So now I'm going to hand it over to Raphael and Mike from Gemalto to talk about some customer success stories.
Thanks, Andy. So at Gemalto, we are a security company from France. Maybe my accent told you that. And we are historically providing security for SIM cards, payment cards, or identity documents. And we have long also moved to services in the cloud for our customers around digital identity as well as authentication services. And so we are really, when moving to the cloud, it's not an easy ride, and it's a bit like going to the fun park. So to really enjoy it, you have to make sure that you can trust the ride and all the partners in the fun. So we do have solutions to encrypt at rest the data, to protect the data at rest, to protect the data in transit. And really, we wanted to go further and protect it while it's in use. So as we are working with Google on numerous topics such as Android security, machine learning, we really accepted the proposal of Nelly to go further and see what virtual TPM could provide us. So why really should we care about virtual TPM? So the first one is that you can have your data being accessed while being processed or in memory, and we want that to be protected. Second is that you can have some code which is not permissioned being executed on your VM, and that's not something also you want. And finally, you have some code that can be modified and which lead to bad execution or to counterproductive measure in your service that you don't want to see. So we did test, thanks to the early access program, the VTPM and the shielded VM, and here is our very, let's say, high-level conclusions. So first of all, it's, as Nelly and Andy shown, it's a straightforward configuration. So it was really really easy to upgrade our workloads on our machines to be sure that they would be running using shielded OSs. So second, we have security teams in France, so they played all along. They tried every, let's say, tricks that they would know, and really every time we were not able to start any VM that was attacked, either compromised with a malware and rootkit, either on Linux or on Windows. And finally, most important, is that it has zero impact on performance, and which is really helping out, especially when scaling down or up. So in terms of usage, we see two. So the first one is really when related to certification, meaning that, for example, on the PCI DSS, which is a payment certification that we take for our customer, there is some requirements on the integrity of the data and on the software. So this is really helping. And second, we also have some very sensitive workload we want to protect, especially around cryptography. And that's what Mike will present you on all the very quick wins we can get from shielded VM. Thank you.
So thanks, Raphael. Appreciate it. So I'm Mike Chirac. I'm in business development, and I kind of want to take this talk towards more and more practical expression and what we envision and how we know our customers are using our products and what they want out of our products when they move to clouds in a more virtual world. So Nelly, Andy, and everybody talked about how the underlying infrastructure can be highly secured now in new ways with great attestation. So the hypervisor, the VMs, but in a shared responsibility model from a security perspective, you guys also have to architect up the stack, right? So that becomes key management, right? That becomes secret management. It becomes DevOps security policy, access controls, and things like that. So for 15, 20 years, Gemalto, through our Key Secure product, has been delivering that on the on-premise side. Now we have a virtual edition of Key Secure, and we want to make sure that that gets deployed in the most secure fashion on every cloud out there. And Google has offered us an amazing ability to do that with shielded VM, right? And additionally, that Key Secure, whether it's tied back to on-premise physical Key Secures or it's just running native up in the cloud for your cloud applications, it tends to also need a client-side encryption component that sits on the application level. So to do tokenization of the data, to do data encryption, to do file level encryption, to do database encryption, there's oftentimes a client connector component to the key manager using KMIP to talk back and forth in a secure fashion. And so having both the application on a trusted OS, on a trusted VM, on a trusted hypervisor provides incredible integrity to our solutions for our customers. Things that they could rely on in our hardened appliance back on the physical data center, and now they can essentially rely on it the same. We're excited about where this is going and where it can go. We're excited about potentially getting connections to external HSMs out of our cloud service or off the customer premise back into the shielded VM to be a rooted trust or to be an encryption key for the database that's running in the key management. We're excited about potentially getting custom images being signed also by Google. So not just your standard OSs, but have custom images available too. And we're excited also about what Google Platform Security has announced with a silo and shielded containers. So a silo is the Secure Enclave open source project that they announced a couple weeks ago, a month ago. And you can see where this goes in this next iteration of why not just run that in a completely shielded secure enclave, right? And so we're going to continue to work to make sure that our products are as secure as possible for you guys and that you can take and bring your own security, develop the same DevOps policies, audits that you're doing on premise in the cloud to make it easy for compliance and make it easy to drag and drop as many applications as you can on the Google Cloud. So thanks, and I think we'll pass it back to Nelly and take questions from you.
And the final words for all of you. So first and foremost, Titan is actually helping us to establish secure foundation for every single workload you're bringing to GCP. We extending this root of trust, hardware root of trust that we have from Titans to VTPMs to your compute resources. And we absolutely excited to ask you to start using our shielded VMs. It's in public beta. It's available everywhere. Our great documentation, website, everything ready for you. So please, please, please start using it, provide us feedback, and we're ready to go and take you to the next level.